In this video, I want us to cover the sequence and series exam questions. So this is covered in question 2 in your exam papers, and question 2 only covers the arithmetic and the geometric series, sequence and series. All right. Here we're given that 2.1, given the sequence 4x 32 going so forth, and we're asked to determine the values of x if the sequence is 2.1.1 arithmetic and 2.1.2 geometric. All right, let's do this right away. 2.1.1, we are told it's arithmetic. So since it is arithmetic, we know that it must have a constant or common difference. The common difference, which is d. All right, so let's use that to our advantage. So the common difference in this case is going to be t2 minus t1, which is also equal to t3 minus t2, right? So you transpose x to the other side, it becomes positive, and then you get x plus x, that's a 2x. That's equal, you transpose 4 to the other side, you get it becomes positive, and you get 32 plus 4, which is equal to 36, right? So you divide by 2 both sides, you get that x is equal to 18. All right, so we are done. We have the value of x if the sequence is arithmetic. All right, now let's go to 2.1.2, which says determine the value of x if the sequence is a geometric. All right, so if the sequence is a geometric, we know that it's gonna have a what? A common ratio or constant ratio r, right? So let's use that to our advantage, and r is equal to t2 divided by t1, which is equal to t3 divided by t2. All right, so now that we have this, let's cross multiply these. What do we get? We get that x, this is x squared, is equal to 4 times 32, that's 128. Please, for huge numbers and big numbers like this, please always use a calculator. I urge you to do that. Okay, so now let's take the square root both sides, and it's going to be x is equal to the square root of that's going to be 8 root 2, right? So this is positive or negative because we are taking the square root, so it's plus or minus the square root of whatever of 128. Okay, so yeah, we are done with this question, and that's about it. Yeah, you're done with it. Okay, very easy and simple. All right, let's move on to our next question, 2.2, and we are asked to determine the value of p if p is equal to the sum of 3 to the power k minus 5 from k is equal to 1 to k is equal to 13. Remember, when we covered this topic, we said, oh, the sigma notation. If you haven't checked that out, please go back and check it out. Okay, very imperative. All right, so remember, we said the first step when you encounter a question which involves the sigma notation, always expand. Please always expand. Okay, now when we do the expansion of this, our p becomes, so the first value that we plug in here is 1, is k is equal to 1. So that's going to be 3 to the power 1 minus 5, right? Plus 3 to the power 2 minus 5 plus 3 to the power 3 minus 5, right? Plus plus the last value is going to be 3 to the power 13 minus 5. All right, let's simplify that, and we get that this is 1 over 3 to the power 4 plus, that's 1 over 3 to the power 3 plus 1 over 3 to the power 2 plus plus 3 to the power 8. Now that we have expanded, what can we do now? So since we have the general term here, this is the general term, remember, and we are looking for the sum, right? We are looking for the sum, but we know that in the general term, we have the ratio r and we can deduce that from the general term, and the ratio r is equal to what? To 3, as you can see it over there, right? But you can calculate it using these, because you have the values now. You have the values of the sequence. Okay, all right, so our ratio is equal to 3, but remember what our equation is. All right, so our equation is Sn is equal to a times r to the power n minus 1 all over r minus 1. Okay, so now what are the things besides r do we need? We need the value of a. We also need the value of n. All right, so the value of n is right there, which is 1 over 3 to the power 4. That's equal to 1 over 81. All right, that's our value of a. So how do we find the value of n? N in this case is not the last term to be substituted, but n is the position or the number of terms in this sequence. Right, so how do we find that? Remember on our last video we said n is found by calculating it in this way. The last number or the last term to be substituted into tk is equal to 13 in this case, minus the first number to be substituted, which is 1 in this case, plus 1. When these two cancel out, and we get that n is equal to 13, right? Okay, so now we have the number of terms in the sequence. We can plug it over there. So this right here is the number of terms in the sequence, right? Okay, let's plug in now. Our Sn is equal to 1 over 81 times r. What is r? R is equal to 3. And what is n? That's equal to 13 minus 1 all over 3 minus 1, which is equal to, all right, let's use a calculator for this one. Let's plug in the values, right? So we get that 1 over 81. Oh, sorry about that. Let me do, okay, 1 over 81 times 3 to the power 13 minus, right, minus 1, right, all over 3 minus 1. And we get the correct answer to be, that's going to be 9,841.49. Right, that's our final answer. Sorry, that's 41 point, yeah, it's 9,841.49. That's our final answer. All right, thank you so much for watching, and please don't forget to like, subscribe, turn on the notification bell, and share with other friends. Okay, see you in the next video.